if you remember, I asked the class rep to follow me to my office so that I can give him the soft copy or hard copy of the syllabus so that you can have them. But unfortunately, I think from the class I went straight for another meeting. And then I fell ill, and then, so you don't have it now. Okay? So after the class rep will follow me and he will have the copy of the syllabus. So that is it. And today we will start the brief introduction about groundwater modeling. We haven't said anything about it before. But before then, I told you we discussed about the Science Direct password, which today is what? I think 3 days ago or so I went to the library to get the password, and I was given the list of all the databases that the university has subscribed to or has the password to. So I have this 3-page document which has the databases and their different usernames and passwords so that you can use them for your own research. One of them is Hinari. I used it so well during my MSc work. It is a database containing a lot of good journals. Also, ISI index journals can be found there. So it's a compendium of a lot of quality journals. The Hinari in particular, which I use, Agora, I think it has to do a lot with, I think, agric-related areas. And then there's Science Direct, in which it says no password, no username. I discussed with the head of the ITU, the ICT of the library, who informed me that the subscription, the university subscription has expired, but they are planning to renew it. However, in the meantime, students can also use the open access option, in the sense that when you, is there wireless in this?
Yes.
There's wireless?
Yes.
And it's working?
Yes, it's working.
It's working? Okay. Just want to show you how to access, because the Science Direct, when you open it, which one? This PG?
Yes, sir.
So most of the articles you have to buy them, but you can, there is an option by the left hand side where you can select open access. So it will give you all those articles that have open access option. And it means that you will still get something. Although you may not have all the required articles you need, but you can still make do with what you have. It is not connecting me, I suppose. No internet. Is it going in your system? Okay. Re is going? Okay, then let me change to Re and see if it will work. Otherwise, okay. It is not connecting. Network here is equally bad. Okay. has connected, but it's saying no. Here? Before it works? So close your eyes. So that you don't see. Yeah, but if you have my username, who knows whether you can guess and then get to my account. But it's still... I just want to show you because it's very important. I will give you this to make a copy because in addition to the databases, you also have free ebooks area. You have bookboon.com, a lot of them. One, I think, but this one, let me erase this because this has changed, this LibGen. It is now libgen.io. Have I mentioned it to you before? Okay. Okay, so libgen.io, you will get almost all the books you need in your different areas, okay, and in their latest versions. All you need is good internet. For the libgen, you can download a maximum of 3 at a time, simultaneous download. So I will give you this copy, but of course it's not for you to just go and keep it somewhere and dump it. Definitely you will use it. Remember our breakdown of the term paper, research summary, and what have you. So it means you have to start working right from day one. More so given that our time now is not, we don't have really the luxury of time. We don't have time on our side. So that is why I'm still emphasizing on this, because they are the tools. They are where you get quality journals. Okay. Science direct. Low battery. Oh, there is no internet. Oh. I think what will happen, I will suspend this, but at your own time, look, go to the Science Direct website. Okay, I think it's coming up. No, this should be a correct one. The network is fluctuating. So this time is good for all of you, 9 to 10, isn't it? Right? So 9 to 10 today, and then tomorrow 8 to 10. Right? Okay. I think it's still taking a lot of our time. So log in. Still. Let me say sorry. When you go to the science direct, just enter any search keyword, and then when you go down, you'll see the option for open access.
It's right at the top.
It's written at the top?
Yes. That's
Where?
open access content.
Okay. No, this is not where you check it. Yeah, but this could, it has not yet, loaded the full web page. All right. Usually at this side, time out. You will see when you write any search keyword, hit enter, it will populate with the articles, and then you go by the side, by the left-hand side at the bottom. You will see open access. When you now select that option, so it will remove all those that are not open access articles and leave all those that you can immediately download. Okay? So what I'm saying is that although the subscription is not active yet, but you can still have access to some of the articles under the Science Direct database. Okay? If you have any difficulty, please let me know. Okay? And then in the meantime also, if you have any article that you want and you can't get access and you feel you need it, you can send it to me. Send me the details of the article, the title, authors, okay, and I will see how to get it for you. Okay? So that is that about that. Now back to groundwater modeling. How many of you are in MSc 1? How many in environment? How many in water? All in water, right? None is in environment. Pardon? For today, okay. Anybody from PG? PGD? Nobody. Okay. So, groundwater modeling, I will just briefly introduce the topic and then we move on to some basics. Probably we may not say something new per se for the many weeks to come. However, modeling, as we all know, entails a lot. We first have to understand the system. We first have to understand it in total, in its totality. We have to understand all the processes taking place before we can sit down and think about how to model that process. For that, you have taken a lot of basic courses at your undergrad, at MSc as well, right from the hydraulics, which you did, 201, 301, 302, 401, 501, and then to the groundwater 503, which you did as well, which is groundwater hydrology, and then to, I think, this 703, the MSc hydrology as well. So you have a lot of basic knowledge to do with groundwater, the processes that are taking place. In this class, we are going back to review almost most of the processes which you have studied before, but now with a view to understanding the process so that we can model the system, we can model the groundwater system. I will not just come and assume that, yeah, because you did groundwater hydrology, so you don't need any review, and just start with the, let's say, groundwater modeling proper, the governing equations, the PDEs, the boundary conditions, the solutions, and what have you. No. Modeling, one must go down to the basis, the theories, and what have you, and make sure that all the salient points. Now we'll go back and review them, but not to teach you as in what is an aquifer, what are the different zones that you have in groundwater, which you already know, because some of you are also teaching the same thing. But now with a particular view to some important points related to the modeling aspect. Because when you come to modeling most of this basic knowledge that we know before will come to play. So we'll just not assume that, oh, you all have all it needs. Even if you do, we'll still go back briefly, and you may find yourself gaining one or two things here and there. Okay? Now, we have groundwater. A lot of things are happening. You may have pumping wells to pump for municipal water supply, for irrigation purposes, for so many purposes, isn't it? At the same time, you may have some injection wells that are meant probably for recharge purposes, for quality control, and what have you. So you can abstract water and you can send water back to the groundwater. Okay? Because it depends on the need. You abstract for use, you inject back for recharge purposes, for quality control, and what have you. But now there are a lot of significant things taking place, in the sense that we need to understand the rate, the quantity first, that can be abstracted without causing undue hardship on the aquifer. In addition to the quantity, the rate, what will be the pumping rate, either of abstraction or injection. So all these aspects can be well managed successfully using the groundwater modeling aspect. At the same time, the issue of quantity and quality as it affects groundwater cannot be separated. The quantity and quality problems as it affects groundwater cannot be separated. Why do I mention quantity and quality? Let me peg them here. Quantity and quality. Quality, yeah. The first one, quantity. The rate, the pumping rate, the spacing of the wells, and what have you. That will determine what quantity can you abstract, and what is even the aquifer volume. Okay? This, those in water resources say, okay, this is what I need only. But in the process, when you are abstracting water from an aquifer, you are invariably affecting the quality. When you abstract for so long a time, the quality of the groundwater deteriorates. The salinity increases over time. Pathogens, nitrates, and what have you. So that is why I'm saying that the quantity and quality problems cannot be separated. They go hand in hand. If you think you are in water, all I'm concerned is the quantity. I can calculate the spacing, the pumping rates, and the volume of the aquifer, and the amount of water present. That's all that I'm concerned about. But your action will affect the quality. So you cannot separate the two. And that is why, even when teaching groundwater modeling, you cannot just consider the quantity alone. You must look at the scenario, you must consider the quality aspect of the groundwater. Quality, like I said, deteriorates over time due to pumping. The salinity increases, pathogens, microbes, nitrates, and what have you. That is as a result of the pumping alone. Then another impact, another scenario that will also affect the quality is the anthropogenic activities, the artificial activities due to human interference, industrial action, industrial waste, leachates from landfills, okay, oil spills from filling station, from underground storage tanks, okay. All these are infiltrating into the ground from the unsaturated zone down to the saturated zone. And also, let's say, disposal of chemicals. So all these will ultimately affect the groundwater quality. And then when these chemicals, let's say the hydrocarbons, some are lighter than water, some are heavier than water. The one lighter than water, they are called LNAPL, like fuel, what we call the PMS. and then we have the kerosene. Okay, all these are lighter than water. Water settles at the bottom. When you mix fuel and water, it settles at the bottom because the density of water is higher than the density of fuel, of kerosene and petrol. And that is why some tanker drivers, sometimes, if they know that their tank is leaking, it has some leak, they put water and then pour the petrol. So that as they move along the road, it is the water that will be draining down because it is heavier than the fuel. So it is the water that will be draining so that probably before they reach their destination, they can now offload the petrol. But of course, sometimes, they may also carry along with it the water, and then you will be the one at the receiving end because your tank will now have fuel and water, which will affect your fuel pump and what have you. All right. So they are called L-NAPL, light, non-aqueous phase liquid. We'll discuss about them later. And then you have the ones that are denser than water, the D-NAPL, dense, non-aqueous. Non-aqueous because it's not miscible with water. Non-aqueous phase liquid. Okay? The one that is denser than water, like the diesel, it is denser than water. So it settles at the bottom. Much the same way when you have an aquifer, it will settle at the bottom of the aquifer. The same thing when you have an extended spill, either as a result of underground storage tank, it will float on top of the water table. And then over time, although the solubility of these hydrocarbons, because they are non-polar, so they have very low solubility in water, most of them, except some few. MTBE has high solubility in water. Benzene has low solubility, but still it dissolves because water is called what? Universal solvent, in the sense that anything that comes in contact with water over time, no matter what, it will dissolve it. Be it metal, wood, building, whatever. So there is nothing that you can say it is 100% insoluble in water. No. Water dissolves anything except that the rate differs from one to the other. So it will dissolve these hydrocarbons and then it will carry along with it. And then when you have a pump well, you will now pump it out and then use it. It becomes, it goes into your system. And most of these hydrocarbons are carcinogenic. You know what carcinogens, right? You did public health. Cancer-causing agents. Most of them are carcinogenic. When you take them continuously over time, they build in your body and then cause one cancer or the other. The risk and what have you, this will be discussed in another course. That is the risk assessment and what have you. All right. Now, what is the issue of management here? Management here means achieving a specified goals or objectives without violating constraints. I have explained most of the activities taking place in the groundwater. How do you pump? What are the quantities, the spacing? Okay? And what quantity do you want to have? These are certain objectives and goals that you want to achieve. But we want to do that without violating some constraints. What are the constraints? The constraint could be the depletion in the groundwater table, because pumping over time, when you pump over time, the groundwater table reduces. And we have also mentioned that the quality deteriorates over time. So how do you pump? Or how do you inject the water without violating all these constraints? This takes us to the management, the groundwater management problem. And how do you do that? How do you achieve the management objectives? Using groundwater modeling. Okay? So this is more or less like an overview, but in the process, like I said, we will consider the quantity aspect as well as the quality aspect. The quantity aspect will take us into the how do we determine the pumping rates, the spacing, the head, which is one of the most important things, the head, the pressure head, okay? And then the quality aspect. In the event that the quality of the groundwater is affected, either due to pumping when salinity increases or when nitrates level increase or when pathogens are introduced or due to anthropogenic activities, underground spill from underground storage tank, from industrial waste and what have you, which ultimately found their way into the groundwater. Now, how do you model it? How do you model the cleanup? But that may be just brief, the cleanup process, the remediation. That takes us to the remediation. When you have a polluted groundwater, how do you clean it? That is the cleanup process or the remediation aspect. So all these are intertwined, are interrelated with the groundwater modeling. So you can see the quality and quantity aspect, they go hand in hand. Of course, you are majoring in specializing in water resources, but still you'll have to know, of course, even in your first semester, you did some courses in environment, isn't it? So even here, although it's not the environment, but it will be mathematical. But modeling, as I always mention, you need to understand the process very well. By understanding the process, you need to understand what are the different pollutants that we have. What are their characteristics? How do they move in the unsaturated zone down to the saturated zone? When they now dissolve in water, then how does it affect the groundwater flow equation? Do you understand? So these are the things that we are going to consider as brief as possible. Okay? So with this brief introduction, we will now move on. This is our lecture number 1. And I hope maybe I have just about, I think, 20 slides. Probably we can finish it. And don't forget, I asked you, when committing my class, you have to bring your calculator, your notebook, your pen, because you will be having a lot of quizzes. When I say quizzes, basically I mean we have 4 types of quizzes. You have attention quiz to test how attentive are you in class in understanding the topic under discussion. And then you have what is called the concept quiz. The concept quiz will test some basic understanding of some concepts which were presented. And then you have there could be a reading quiz just at the beginning of the class to now like an appetizer. When you want to eat food, although here we don't usually have it, but normally where attention to food, where food is well taken care of, you normally have an appetizer. Something that will ginger you up, that will like stimulate your, all the faculty of the different departments responsible for, eating, digesting, and what have you. And then you have the main meal. And after the main meal, you have the finisher or desserts. Okay? So the reading quiz is usually like an appetizer that will stimulate your brains and then, okay? So all this, sometimes they will need you to write down some things, do some calculation, and then you will tell me your answers. They are not really meant to put you in trouble, but just so that when you come to class, you should put everything aside. Your attention should be here, your focus should be here. Because all this, like I mentioned, there are some basic things, but still in the basics, you have a lot of important points which we are going to utilize. Okay? So we cannot just presuppose that, you already know this, so we will just start with the modeling proper. Okay? So today the outline is, we'll start with the first thing in hydrology, the groundwater in hydrologic cycle, and then zones of porous media, and the types of aquifers. First and the second one probably we can exhaust in lecture 1, but the types of aquifers, okay, probably even the third one, okay? But I hope time will permit me to go through it. But one thing I will have to emphasize here is, for anything you feel you have any question, any doubts, feel free to voice out your concern. Ask questions. If you have seen the way I started, okay, though I haven't yet started, but I will ask a lot of questions. So even if you don't ask me questions, I will definitely ask you. So if there is anything that is not clear to you, you have to understand every bit of the lecture very well. Because like I mentioned, modeling, that's why not difficult, but you need to understand the basis very well. It has to be clear to you. Because you cannot predict a system that you are not aware of, a system that you don't know much about. So you have to know everything to do with the system. Then you can use your mathematical intuition to sit down and now try to express the system mathematically, or try to predict the behavior of the system under certain scenarios, which is what modeling is all about. Okay? So, groundwater in hydrologic cycle. We have different names for the hydrologic cycle. We call it water cycle. We call it hydrogeologic cycle. Okay? So, whatever name we call it, that is the beginning of hydrology, isn't it? Where we normally have water. It's a closed cycle. A closed cycle, you have no loss, isn't it? It keeps on moving. It just changes phases from one process to the other, from one process to the other. You may never know where it has started, but although we can only start, from precipitation, but it goes there also via evaporation and evapotranspiration, and then it accumulates, and then when the geographic, whatever you call it, dew point and what have you, the saturation point, you have precipitation on land, which usually some of it infiltrates to recharge the groundwater, and some will so as to constitute the groundwater flow. This is the this is the groundwater, the water table. Okay, and some will fill the depressions that we have on ground to form rivers, streams, and lakes. And here you have dam, and at the same time, the surface waters, you have rain hitting them, sun. Though even in the absence of sun, evaporation takes place at all temperatures, isn't it? Evaporation takes place at all temperatures. This we know. So, and we have the transpiration from plants, from the stormwater water going out, constituting back, the moisture over land and what have you. So you have humidity, and then it moves up to form the clouds, and then the cycle continues. Later we are going to discuss input and output in our model, in our modeling techniques, okay? But then here, you see this is a closed cycle. Although, like I said, this is a closed cycle. So what about if I ask you, how does it start? From which of these phases does it originally start? From the beginning of time. From evaporation. Yeah, there is always a starting point. Even the world started from the Big Bang, isn't it? You have, an energetic atomic part, then it explodes, and then the galaxies were formed, the planets were formed, and then they keep on moving apart, and then we have our world and what have you, isn't it?
Why I say that, because it has not end point. Since that is a closed cycle.
Yeah, that is. Now it is a closed cycle, but the geologists have told us that it started. The core mantle of the Earth is extremely hot, isn't it? And you have a lot of volcanic eruptions here and there, which one of the components you have is moisture. So they are postulating that it originated the original source of water came from the earth itself through volcanic eruptions as moisture. And then when it comes out, it settles on land, and then the cycle started. That is what the geologists have told us. Okay? Now, yes?
That reddish thick line.
What?
That reddish thick
Oh,
line.
now it's better. That reddish, okay. You can see low permeability strata. We are going to explain. It's an aquitard. Aquitard, low permeability strata, like clay. Okay? Because like if you see from the outline, we'll discuss types of aquifers. So it is one of them. The low permeability strata is like a dividing line between this and that. Okay? Now, types of terrestrial water. Here you have the ground surface, the soil zone or the unsaturated zone, which consists of, this is the soil zone, and then this is the capillary fringe, and this is the saturated zone. We are going to explain in details all this. This is like a soil horizon. Saturated zone below the water table, which we call the groundwater. You can see the capillary fringe also almost indistinguishable with the saturated zone. We are going to explain what differentiates the capillary zone with the saturated zone. That is the groundwater. You know, when you sunk a well, it comes up. And then this is the unsaturated soil zone, where you have the root zone and the soil moisture. And then this is the surface water, streams, rivers, and what have you. How much water do we have on Earth? We all know that saline water constitutes most of the amount of water we have on Earth, which is constituting about 97.2%. Then we have the ice caps and glaciers, 2.14%. Groundwater, 0.61%, very small when compared to the total amount of water we have on Earth. Surface water, 0.009. What is the percentage of surface water with respect to groundwater? How many times is the groundwater greater than the surface water? Can you tell me? Can you calculate it? And then we have the soil moisture, and we have the atmospheric moisture, the atmosphere, the water found in the atmosphere, 0.01, very small. But then, of great significance to us here is the groundwater and the surface water, because they are interrelated, isn't it? The surface water contributes infiltration and also down to the groundwater. Okay? About what? No. 67 point, about roughly 68 times. The groundwater is greater than the surface water in amount by about 68%. Okay? 68%. Okay. But here, most of our sources for municipal water supply is what? Surface water, isn't it? It's surface water. The unsaturated zone, zone of aeration, and the Vedas zone. This is a typical profile of soil. You have the land surface, you have the soil water zone, and you have the unsaturated zone, and this is the water table. And this is the saturated zone. Now, what are we considering here? We are looking at the matrix, the soil matrix. For the unsaturated zone, pores full of combination of air and water. For the unsaturated zone, this is the soil matrix, the grains of the soil. You have some void spaces, isn't it? These void spaces are filled with air and water, because you still have soil moisture, isn't it? So you have air and water making up the void, or filling the void, isn't it? And then you have the soil grains, or the sediment particle, isn't it? These are the constituents, and like air and then some water. But what about the saturated zone? For the saturated zone, you have only water filling the void, no air in that case, isn't it? All the air has been expelled out and replaced with water. And then you have the soil grains. So that's why it's called saturated. Okay? And the other one unsaturated. So this is the zone of saturation. And here pores full, complete. They are full and completely filled with water. Now, we have seen the percentage. That of water, groundwater is about 0.61, isn't it? Percent of the total water we have on Earth, and that of surface water is 0.0009%. Now, let's quickly compare and contrast using groundwater or surface water as sources for municipal water supply. What are the merits and demerits for each one? Give me one.
Groundwater is basically of better quality than surface water.
Okay. So probably it will require less treatment.
Groundwater is, in terms of quality, the quality of groundwater is better than surface water.
That is what he is saying. Give me another one.
Groundwater is.
You can give me demerit both ways.
Let me say, it's always more available than that of sometimes, because sometimes you might have short of the surface water you have in a particular area. It will be like you're depending on the stream, the head is high after some time.
That could be relative when you mention available, because what about if the underlying aquifers do not have appreciable amount of water? It is not all the time that the aquifers must have appreciable amount of water. Okay, and that's why we have aquifer and aquitard and the different names that we are going to explain.
But also surface water
So,
is easy to tap sometimes than the groundwater. It's easy to, in terms of collection, it's easily accessible.
easily accessible?
For collection than the groundwater.
Easily accessible.
Yes.
So now you change.
Yeah, I'm just giving different things.
No, the other time you mentioned groundwater is easily accessible.
I said it's more available.
What do you mean by more available?
More available is that in terms of maybe, for instance now.
In terms of quantity, because if you say more available, it means which we already know. 0.61 and 0.009, isn't it? So in terms of quantity, yeah, that one we know. So tell us something else.
So I said, in terms of collection, for instance, it's easy to collect surface water than groundwater, because even a layman can go to the surface water and collect a quantity of water. Maybe it's easy for them to even treat in terms of not requiring a scheme, because you can take
the surface water.
Yes, you can take.
But that's exactly the opposite of what should be.
You can take surface water, add along to it locally, and you treat it.
Yes. Surface water, as we're going to see, usually needs more sophisticated, the treatment methods are higher than that of groundwater. Groundwater needs less amount of treatment, less treatment than surface water. Because already the water has underwent filtration naturally when passing through the pores, isn't it? So it is already filtered. And then, what?
I said initial cost may be high.
What is the initial cost? Sinking well? What is the initial cost of sinking well? Sometimes you can have the groundwater as low as 2 meters, 3 meters below the ground level, isn't it? While that one, you will have to have what? A dam first. That's the first thing. And you know better than, you know better when it comes to, the amount it takes to build a dam. And then you have a treatment plant. Right? What? What do you mean by distribution system?
Additional cost of construction.
Yeah, although even groundwater, it can be, pumped to the treatment plant. Because all we are saying is that groundwater is not as polluted as surface water. Surface water, because it is on the surface, so all communities around the area can dump all their waste And even air, wind, and what have you can carry all the waste, and just dump it there. So it is usually more polluted than groundwater. And groundwater, because it seeps due to infiltration, precipitation, and what have you. So it undergoes natural filtration. Okay? It undergoes natural filtration. So that when you gain access to it, it is usually clean. The normal treatment for groundwater, let's say for municipal, so let's say when you sink a well, a borehole, you can even take it as it is, because when you do the water quality analysis, you will find it suitable. But then the minimum treatment should be disinfection and filtration, even for your wells or your borehole. For filtration, now you have some filter packs which you can attach to your pipe leading to the tank, okay, which has some filters, disposable filters, 500, 600, or 700, which you now change over time, which will filter the water going up to the tank and down into the distribution line. So that should be the minimum amount of treatment, because normally when pumping you may have some debris coming along with the water. And then again, there will be need for some disinfection. Disinfection, when you go to you can buy chlorine, the granules. I normally buy it from what they call coli. I don't know what you call them. Coli. When you go to the market and ask for coli, they usually have this chlorine. So coli, they sell different types of. What are the things that they normally sell? Coli. Even alone. So when you go and ask them, you want chlorine. Except that as a water engineer, you won't know the specifications. What is the concentration? What is this? What is that? So usually just take 1 spoon, dissolve in water as much as possible, then put inside either your tank or the well and stir it, okay, with a bucket. So this is the minimum treatment that you should have. But then at the same time, like I mentioned, for municipal, this is for like domestic supply, 1 house, 2 houses here and there. You can also use it for municipal water supply, in which you can pump it to just much the same way you have dam, the water is being pumped from the reservoir to the treatment plant. You can also do that. You can pump groundwater to the treatment plant, and then depending on the quality of the groundwater, it can undergo the other processes, let's say coagulation or filtration, and then disinfection, and then depending on the need, okay, it can be expanded. Now, in terms of quantity, we have agreed that, groundwater is higher. Quality, groundwater is also better than surface water. Sustainability. What do you have to say about sustainability? Oh, my time is up. So, tomorrow, let's all be here at 8. Today I came before 9, but I know sometimes when I come early, I may walk up and the place is locked. So I went to my office and told myself that whenever you are all around, okay, then you can come and call me. But tomorrow, let's be here at 8, and we can all start at 8 so that we have good time. This is just slide 8, and I have 20 slides. And like I mentioned, all this may be things that you all know, but at the same time, there are a lot of salient points that we are discussing and introducing. Okay? So this is how the class is going to continue throughout. Okay? But we really need time to work harder, because there are a lot of things to cover. Even from the background stage, before we go into the groundwater modeling proper. Okay? So any question before we call it a day?
Are we going to have this
Definitely. You will have it. Okay. All the materials, I don't know if someone can create a WhatsApp. Can you create a WhatsApp group? Huh?
We have WhatsApp.
Okay, for your class?
Yes.
Is it for the MSc1 class?
Yes. I know. For MSc1 class.
Okay. So
No, we want to say okay, so I thought okay. Okay, we can create groundwater modeling.
Yes, since because some are not in MSc1, isn't it? So can you create another one, please? Because through that I can share all these documents and then you can download them from your phones, your systems, and then it makes life easier. Okay? Please do that as soon as possible, and then you add me. Okay? Now I'll go to the office. I will give him this. You'll go and make copy, and then try it out. Okay? And then I will give the syllabus, a copy of the syllabus, so that you can make copies and have a copy, and then have my attendance. Anybody? I have the MSc1 regular. I have those auditing, and then the PGD.